Recursion. So this is the topic of today's lecture. We are going to look at what's called as recursion or recursive functions. Functions which call itself. That's recursive functions. We have seen till now, so we have seen how to define functions and how to call functions. These are things we have already seen, right? And today we are going to look at a special case of functions which are called as recursive functions which call itself. And it's a very fundamental idea in computer science. It comes up in various this notion of a recursive function or recursion, etc. These are the very fundamental idea in computer science, and it's going to come up in lot of other courses. It comes up in mathematics as mathematical induction. It will come up in your logic course as inductive definitions. It will come up in your algorithm course because there is going to be a lot of algorithms which are going to be written in a recursive way. It's going to be in your automata theory course because the grammars are going to be defined inductively. So in all these ways, so in that recursion is basically it's going to be there in all your fields of computer science. So this is a very important topic which you need to understand. That's one thing. And if you are going for a job placement or you're going for higher studies, etc., this is the first thing everyone is going to test. You tell him I'm from computer science, they're going to test whether you know recursion. If I am an interviewer, I would be testing first for recursion, and like the interview proceeds further only if he or she can answer some question you ask in the about recursion. Okay, so this is a very fundamental topic, and that's what we are going to look at today. So what is a recursive function? We are trying to say a recursive function is a function which is going to call itself, right? And so let me consider the following problem. So I am going to give you a problem right now, and then we write a recursive function to solve that problem, right? So the problem we are going to see, so the first problem people always see in a recursion class is basically what is called as the factorial problem. So that is, you are given a number n, you are interested in finding out n factorial. And what is n factorial? N factorial is 1 into 2 into 3 up to n. Okay. So the product of all numbers from 1 to n is called as n factorial. And now you need to write a function which basically outputs n factorial. And you need to write it in a recursive. You need to write a recursive function which outputs n factorial. Okay. So a recursive function consists of two parts. So whenever you write a recursive function, you need to see it should have two parts. First part is, I would call it, as a base case part, and the second part will be the recursive step. Every recursive function you write should have both these parts, and if either one of them is not present, you have not written a recursive function, or there's something wrong, you are wrong. So every recursive function should have both these parts. Now, what is the base case part? The base case part is basically telling you what should the output be when your input is the simplest form. Okay, the easiest input. What do we do for the easiest input? For the simplest input. So for an input which we know for sure what the answer is, so that's going to be usually the base case part. Okay, and the recursive step is the part, the block of code where you are going to call this function recursively again. Okay, so so both these parts should satisfy certain conditions which we will see later. So okay, now to summarize, every recursive function should have these two parts, base case and recursive step. Okay, now the next thing we are going to do is I am going to write a function, a recursive function for computing n factorial. So I am going to call it factorial function. So I can call it function factorial. Okay. What should the input of this function be? So as we know, for factorial, what we take a number n and outputs n factorial, right? So the input should be an integer n. Okay. And what should its output be? Output as n factorial, and output should, we have to, in C syntax we have to write the type of output. What is the type of output here? The type is also going to be integer. So we have to write int. So the function name is func underscore factorial. Okay. So the return type is int, and the input, the function takes as parameter an integer n. Okay. Now next step is the function body. The body of the function. What does it contain? So we have to see, there are two parts. Every recursive function should have two parts, the base case and the recursive step, right? So I am going to write the base case first, and then I will write the recursive step. Now the base case first. What is the base case? What is the simplest case for the factorial? So simplest case for factorial is 0 factorial. What is 0 factorial? 0 factorial is 1. Okay, right. Now, so that's the base case. Now, so I have to write if n is equal to 0, return 1. That is, if the base case is your input, you are going to return 1. Okay, because that's 0 factorial is 1, you are going to return 1. Right. So let me just write here as a comment. What does this function do? Because this is something you have to write. Whenever you write a function, you need to write what this function does. What does this function do? The function takes as input so the function takes as input an integer n and outputs its factorial. Output in the here means it returns its factorial. Okay. So so we have to keep in mind that whenever I return, the return has to be correct, right? So when the input is 0, I have returned 1 because 0 factorial is 1, and therefore this is correct. Now, what is the next thing we are interested in? Next thing we are interested in is the recursive step. Okay, so this is basically my base case. So this is my base case. Okay. And now my recursive step. What is my recursive step going to be? So in the recursive step, this is the idea behind thinking recursion is the following. You have to see the following. You have to think along these lines. Okay, if I know the solution to a simpler problem, or a simpler instance of the same problem, can I answer this question? That is, if I know the factorial for a smaller number, can I answer factorial for n? That's the way you should think for recursion. Okay, so you're going to think, if I know factorial for a smaller number, can I write factorial for n? It's clearly that if I know the factorial for n minus 1, I can write the factorial for n, right? Because the factorial for n minus 1 is n minus 1 factorial, and n factorial is n into n minus 1 factorial. So once I know that logic, it's now going to be clear. So I can write, so this is how I'll write x is equal to function factorial n minus 1 right? So if I know the factorial for n minus 1, which is n minus 1 factorial, then how can I output the factorial of n? So what is it? That is n into this x, right? So I have to return, so I return okay. Is this clear? So what I did here is that in the recursive step I have identified a smaller problem. Okay, the smaller problem is the factorial for n minus 1, a smaller instance of the problem, and then I took the output of that, the return of that, I took its answer and I built the solution for the bigger problem of n. So that's how you think about recursion, and this is my recursive step. Okay. So all my all my recursive functions will contain these two parts, the base case and the recursive step. Now there can be it can happen that so right now in this function the base case is just one line of code. I just checked whether n is equal to 0. So that's n is equal to 0 is the only base case here. But it in that may not be the case always. You could have a base case where there are multiple values. N could be not just 0. I can also check for n is equal to 1 or n equal to 2, etc. So the base case can be of for multiple values. Okay. So for example, I could have had here. I could have written here the following extra condition also. If n is equal to 1. If I return this is also part of the base case. Okay. And this is also correct because 1 factorial is also 1. Right. But this is an irrelevant base case. Even if I add this base case, it does not affect my correctness, or my function is still correct. Right. But this is unnecessary. But let it be there for our time being, because it's not wrong. Okay. So so the point I was trying to make is that base case can have multiple lines. Okay, multiple conditions can be part of the base case. So these two parts. So this is also base case. Similarly, the recursive step can also have multiple parts. Okay, so the recursion we are seeing right now is called as, this is called as linear recursion. First of all, why is it recursion? Because there is a recursive step where I call the same function factorial again. That's why it's recursion. And it's called linear recursion because I called it exactly once. That's why it's linear recursion. But I could have called it multiple times. If I call it 2 times, it would be called as binary recursion. So linear recursion because recursive call exactly 1. I could have had binary recursion. So where the recursive call is exactly twice. Okay, so I will have 2 lines like a function factorial. Okay, 2 times I call that, then it becomes binary recursion, or it could be more. Okay, or multiple recursion where I call it multiple times, where I call the function factorial multiple times, not just once, not just twice, it can be more. Okay, so first, this function which we have written basically does linear recursion. The factorial does linear recursion. Next thing we are going to do is the following. I am going to check how this function is executed by the machine, and we are going to see for a small value of n how does this factorial function gets executed, and we will go through the steps of the execution for this function and try to understand it clearly what is happening here. And then and after that we will see how do you check whether a recursive function is written correctly. That is your argument correct? The recursive function you have written, is it correct? That's something we'll see how can we do that. That will be the next thing. So the first one, for a small value, let's say a value of 3, how can I say this function is correct? So I'm going to call this function. From our main program, for example, and call it fnc underscore factorial 2. So I'm going to call this function. So let me call it factorial 3. Okay. I'm going to call this function factorial 3. What is the output I want? I want 3 factorial or 6, right? This is what I want. Now I'm going to start running here. So the first thing I'm going to do is I'm going to draw some blocks. Okay, and inside, so this is a block for the factorial function. Okay, so this is, I can write here fnc factorial. So this is the block for that function, and into this block I am sending for n is equal to 3, right? That's what I want to execute. So I have, when I enter this function, so I call n is equal to 3 from here. The function goes, so the machine goes here, it comes here, right? The machine comes there and it sees it's going to assign n is equal to 3 from there. So I have put n is equal to 3. Okay, and what does the machine do again next? So it's going to come here next. It's going to check, is n equal to 0? Is n equal to 0? Is 3 equal to 0? No. So it's not returning. Is n equal to 1? No. It comes next. X is equal to function factorial n minus 1. So that's the next thing which is going to be executed, right? Okay, so one thing, I mean, so this code won't be compiled because I didn't write what is x here. So it should have been, I should have had int x here, right? I should have defined it's an integer x. Okay, now so I have fnc factorial n minus 1, right? So that the function is called again with n minus 1. What is n minus 1 here? N is 3 now, as we know, and it's going to call n minus 1, 3 minus 1, 2. The function is again going to be called again, so n is equal to 2. So now when I'm going to call again, I'm going to draw another box here. I'm going to have a smaller box. That is basically again function factorial because it's called again, right? And what is the n value here? This is n is equal to 2. So note that the program is executing from here. So I am basically trying to copy what the program gets, how the program is getting executed. So it starts with n is equal to 3. It comes here and it sees n is equal to 2. And it sees so n is equal to 3 now, and then it calls the function factorial again with 2. That's what. So when I call this again, I have put because it's going to go here again, right? When this is called, it's going to go here again, but it's a different value of 2. So therefore I have written a block of code here. And what is going to be x in the first case? When I had n is equal to 3, it's coming down like this, and I want to assign x. What is the value x gets assigned? X gets assigned the value of the return of this, right? The return of this function called, right? So whatever this function gets returned, it's going to be assigned to x, right? So I have to first run this function and see its return, and that gets assigned to x. Okay, so I start from n is equal to 3, I come here, I reach here. So first I'm going to execute this function, and then that value I'll run there, get stored in x. So that's this block. So this block is basically this function code, right, with n is equal to 2. Now n is equal to 2 gets called again, so it goes there again. So n is equal to 2 gets called. Is 2 equal to 0? No. Is 2 equal to 1? No. So it comes here again. So again we don't know the value of x. Again to fill the value of x in this block of code, so we have an x here, right? So let me say initially I put x is equal to 0 here, so I have x is equal to 0 also here. Okay, so I have x is equal to 0 also here. In the first part of the code, x is equal to 0 in the beginning, and the second part of the second block also x is equal to 0, and n, but n is equal to 2 here. You should always keep in mind that these two x's are different. This x is in the first block and this x is in the second block. Okay, so I am here with n is equal to 2, I come here, these two things are not called, I come here, and I want to see, I call the function factorial with n minus 1. N is equal to 2 here, so I call it again n minus 1. So again, when I am going to call the function again, I have to write another block here. I draw another block here, right? And what is the, when I call this function again, what is the value with which I call that function? I call the value with 2 minus 1, that is 1. So I call this function again with value 1. So that becomes n is equal to 1. And so with n is equal to 1, this function gets called here. So it comes inside this and assigns x is equal to 0. And then it comes here. This statement is not executed right now because n is not equal to 0. Next is n is equal to 1. When n is equal to 1, this if condition is correct and it returns 1. Okay, so this block of code returns 1. Where did this block of code return to? Okay, how did this block get called? This block got called from the block with n is equal to 2. That block called this function and it wants to assign the return of this function to the x of this guy, right? Okay, so this return will be assigned to this x, right? So this x becomes 1. Okay, so I will write, so in this case I will write this as the following. So I will have x is equal to basically this block of code, right? Because x is equal to this block, so I am going to this factorial call again, so x is equal to this block, and that is basically the return value. So x becomes, at this point x becomes 1. Once this entire block gets executed, x becomes 1. That's the return value. Now, so x is 1. And then what does this block return now? This block is one function called, right? What does this block return? That block returns n into x. So what is the value of x here? The value of x is the return for this block, and the return for this block is 2. So the value of x we will note down here, x is equal to 2, right? Now, what is the return for this huge block? The return for that block is n into x, right? So return is this n into x, and you have to see what is the value of n in that block. The value of n is 3, and what is the value of x in that block? The value of x is 2. So the return is going to be 3 into 2, which is equal to 6. So the return is 6. Now that's correct, right? Because 3 factorial is 6. Okay. So the return from this, when I call this function, the return for this function will be 6, and it's correct. Now what I could do is that I can change it to 4. What happens if I write n is equal to 4? I call this function for factorial 4. Now to call factorial 4, I should have a box outside with n is equal to 4. Okay, I'm having a box. I'm having a box with n is equal to 4. Okay, and the box. So when n is equal to 4, you come here, and then you reach this function where it is the function called to factorial n minus 1 or factorial 3. So there is this function called to factorial 3. I already have this box for factorial 3. So I'm basically calling this box. So I could write it like exactly like this. I call this function factorial, the box for factorial 3, and get x, the return of this function. What is the return? The return is 6, therefore x is equal to 6, right? And then what will be the return for the execution for this outside block? The execution for that outside block is return of n into x, and that is return of n into x. N is 4, x is 6, therefore return is going to be 4 into 6, that is 24, and that's exactly what factorial 4 factorial is. So this is a block way to see the execution for your recursive function. Okay, and it's good to see get this pictorial view of execution. Okay, so we'll also try to code up this function in C, and see, and I'll also try to print this its execution, the run of the code. We'll try to print that, but only there will be only slight difference with this box notation, is that it's difficult to draw this box, right? So since that's difficult, what I will print is we'll do a shift. There is a shift here happening, right? Already there is a shift here. So first block is all printed here on this line. The second block is printed after a shift. Third block is printed another shift. The innermost block is printed with a further shift. Okay, this is what we will also do in when we code. So few things you need to notice. What is the innermost block? The innermost block is the base case. That's the crucial observation. The innermost block is the base case, and so that's what that's an observation you have to keep in mind. And each of these calls are basically the recursive step. The call to a block inside is the recursive call which we make. So every again we come back to the properties of a recursive function. It basically will have two parts, a base case and the recursive step. Neither of them can be missed, both of them should be there, right? That's recursion for you. The next thing we are interested in is, how do I check whether the recursive function you have written is correct? Correctness of recursive functions, that's the next thing. Now to check for correctness, a recursive function, you should look for three properties in the recursive function. Okay, and the three things you need to see to check whether your recursive function is correct. So I'm going to list them down. First thing you need to, I'm going to list them down. The first thing you need to see is the following. Is the base case correct? That's the first thing you need to see. Is the base case correct here? If n is equal to 0, return 1. Is the base case correct? What is the function doing? The function says it takes as input an integer and outputs as factorial, right? So you need to again go back, think what is the function doing? And is this function doing correctly for the base case? For this base case, the input is 0. Is it correctly outputting the return is correct? The return should be 0 factorial and 0 factorial is 1. So therefore the base case is correct in this case. So I put a tick mark to indicate that okay, it's correct, the base case is correct. This is what you will have to do also. Next thing you need to check is the following. So the next thing we need to check is the following. Is there a reduction in value of n in the recursive step? N is here. In general, is there a reduction in value of the input parameters in the recursive step? That's the next thing you need to check. Why do you need to check this fact? Okay, so assume that I had called this thing factorial n plus 1 rather than n minus 1. What happened to the box case? Right? Imagine the box we are trying to do. The outermost box will be 4, right? And then the inner box comes with the call to factorial of n plus 1, that is factorial of 5. So this is the outermost box with n is equal to 4. Then the innermost box will come with n is equal to 5. Then you go again inside with n is equal to 6. Keep on going. N is equal to 7 and keep on going. When does it stop? It never stops, because it's always going to be here. It's never going to be the base case. We observed that the innermost box is always going to be the base case, right? And if I had put this n plus 1, you are never going to hit the base case. It's always going to keep on going. What does that mean for your program? In your program, it means that the program is not going to stop. It's going to execute. It's going to continue executing forever. This is something you can try and see that the program will never stop. It will keep on doing it. Keep on running. That's not what we want. We want it to stop. So you need to ensure that there is a reduction in value of the input parameters in the recursive step. You need to ensure that. Otherwise, the program will never stop. So you have to think. You have to check whether you have reduced the parameter value. Okay. So, but sometimes it's not the value reduction you are interested in. So it will be slightly different, because sometimes you might, if let's assume your input is basically an array. In that case, you are not interested. It may not be the value you are interested in reduction, but maybe the size of the array. The input array might be 100 elements, and when you call the function again, the recursive call again, the size of the array might be 50. I'm saying it's lesser than the input array. You started off with the array of size 100, and the recursive step, the size of array becomes 50, and further recursive step, size of array becomes 25. It's an example I'm trying to say. So in that case, again, it's not the size, it's not the value which reduces, it's the size of the array which has reduced. So there has to be some form of reduction, either in the size or in the value, whereby you can see that you can ensure that the base case will reach, and it's not going to keep on running forever. So check whether there is a reduction in value, or I can put or size. So is there a reduction in value or size of input parameters in the recursive step? That's the second thing you need to notice. Okay. So the third property is basically to check whether is the function totally correct. Okay. So now, what do I mean by totally correct? What I'm asking is the function correct all the time? That is, for any value of n, is the function going to be output? Is the function, will the function return the correct value for any value of n? That's what we need to find out now. We have checked now whether the function is correct in its base case, when it's n is 0 or n is equal to 1, whether the function is correct. We have checked that. And we have also checked whether the function is going to stop after some time. That is because at every step we have that the value is going to reduce. So we have checked that part also. Now comes the third part. Third property, you need to check whether the function is going to be totally correct, going to be correct all the time. Now to do that, what we will do is the following. We are going to ask to do this check. You are going to assume You're going to first assume whether the function is correct in the recursive step. You're going to assume that the function is correct in the recursive step. That is, if I have to prove that, if I have to check this function is correct, I am going to assume that if this function is correct for this n-1 case. That's my first assumption. I am going to assume that this recursive step, the return value is correct. So in this case, the return value of this function is going to be n-1 factorial. I am going to assume that x is equal to n-1 factorial. Now if I assume that, can I argue that the return value of this function is n factorial? Okay, and now use this assumption and verify that the return of this function is correct. Okay, so that's the final step. And now how do we do this? So if I assume that x is n-1 factorial, what is the return? The return is n into n-1 factorial, that is n factorial. So for input n, the function returns n factorial. Assuming that the function returns n-1 factorial correctly. This is what we want, right? Because we said that assume function is correct in recursive step, and using that assumption, can I argue that the function returns correctly? That's exactly what I have argued now. I have assumed that x is equal to n-1 factorial, and I can now argue that the return is n into n-1 factorial, which is n factorial. That's correct, because we wanted n factorial because our function is the factorial function. Therefore my function is correct in all the three conditions. If you, for any recursive function, one can show all these three things are ticks for in the recursive function you write, then you can say that this function is correct always. No matter which input is given, this function is going to be correct. Now even if this function is now embedded in an aeroplane, you can safely go into that plane because you know that this function is always correct. You can, so that's the beauty, that if you check, that's the main reason why you need to check for these three conditions in a recursive function. Okay, thank you.